Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to take a look at the computer that's inside this box. It's a viewer donation, and normally that would be on a Super Mini mail call video on the second channel, but I think this machine deserves its own main channel video. You've already seen the thumbnail and probably the title of this video, and yes, this is a BBC Master. I think it's a 128. It's a computer that, let's just say, is pretty rare in the United States. I know pretty much nothing about it, other than I think it's in good shape, but who knows really. So after the break, I'll open this thing up and we'll take a look at it and see if I can get it working. So without further ado, let's get right to it. So I'm just gonna cut into this and hopefully it survives shipping. So this came from viewer George. He reached out to me and had one of these, offered it up, and I said, of course, yes. I have a couple BBC regular model Bs that I picked up on business trips to the UK, but the Master, from my understanding, is a later, more evolved machine. I think it comes with 128K of RAM, 128K of ROM, and it's just more capable than the original BBC. So George did a really good job at the packing here, so I'm just gonna extricate the computer from the box. Now, when George emailed me about this machine, it was quite a while ago. He sent this in. I think I've had this for a number of months here in the basement. I just haven't gotten around to opening it because I'm always so backlogged on my mail call items. Alrighty, and with that, I think we have the computer in here. Still in, looks like another box and more bubble wrap. This is absolutely amazing. Let's just take a quick look at the other stuff that came inside the package. So one of the things I asked George to do before he sent this out, since he was going to be shipping this, was to go pick up some of this UK style jelly, which is known in North America as Jello. Sugar-free stuff from Hartley's. It's relatively inexpensive, but they have some different flavors that I kind of like. Lemon and lime, several packets of that. And then some of the best stuff here, black currant and sugar-free. Here in the US, you can buy Jello brand stuff, but all you get is the most boring stuff. It's like strawberry and cherry, and it's like the fakest tasting of those things. So it's always nice to have a little bit of a change. And anytime I go to the UK, or actually any country for that matter, I always go shopping in the supermarkets and check out various things like this. And if they have anything that looks really good, sugar-free, I will grab it for myself and bring it home. Case in point is that sugar-free Tang that I always buy in Mexico, because that stuff I really, really enjoy. And as a diabetic, just like this sugar-free Jello, it's a good way to get something sweet when I'm not able to just have the regular Jello or candy or drinks or whatever that's really sugary. So we got a couple mugs in here. Look at that. ARM, as in Acorn RISC machine. And yes, ARM, like the ARM processors and basically everything at this point, our phones and everything else. Well, that all stems back from the Acorn that made this computer. That's something that people may not realize necessarily. These original computers, like this one, 6502 based, although as far as I'm aware, actually, this particular computer has a variant of the 6502 that I had never heard of, the 6512. But that's awesome. Thank you very much, George, for the ARM cups. Yeah, I'd never heard of the 6512. So when I was doing a little bit of reading on the BBC Master, I was like, what's the 6512? It seems like it's a lightly modified version of the 6502 released by Rockwell. And from what I can tell, there's no actual difference, except it has an extra pin to disable or enable the data bus lines on the processor. Also, the way it generates the clock signal is a little bit different. Typically, a 6502 has a clock input signal. It's a pin on the chip, basically, and it outputs Phi 1 and Phi 2, which are two slightly different clock signals, and you run the whole computer off of that. With this processor, it appears that you need to generate those signals externally, and it used that extra pin, which used to be the clock input, as that data bus enable pin. There's the UK plug. If anyone hasn't seen that before, goes into the wall like this. It's a cool design. It's very chunky, as you can see. It's a cool design because when it's in the wall, It's designed so if you tug on the cable, it doesn't easily just pull out of the wall. We're still peeling back the layers. There's the final box. I think the computer is actually inside of this thing. It does sound like there's some stuff floating around in there. It's interesting because when it was all wrapped up, it felt like a solid mass. I didn't hear anything at all loose inside. It looks like we're getting closer. There it is. There's the computer. Awesome. Let's get this out of here. And there it is. Take a look at that. F0 through F9. We have, versus the regular BBC, we have a full number keypad over here. It also has 2 expansion slots. That one seemed a little bit jammed, but you have, well, I guess cartridge slots actually is the correct term. We have a little bit of case yellowing. BBC is stamped right into this, like melted into the plastic. So I feel that maybe this was used actually at the BBC. I don't really know. I don't remember all the details. We have an M logo down here, British Broadcasting Corporation, Master Series microcomputer. It also has that same logo and the same writing. There are some LEDs here, power LED, caps lock, and looks like shift lock. And on the bottom side, we see television network. So maybe this really was used inside the BBC or something, network 23. Please use a cartridge. Do not use the internal PROM sockets. They wear out quickly. Right here it says made in the UK by Acorn Computers, model number, and there's nothing written there. Now right here's a sticker that does have me a little bit worried. And I just was doing some reading just today about this machine. This product contains a battery. Refer to welcome guide and any addendum on replacement instructions. Let's hope that that battery is not in this computer because, well, it's probably a nickel metal hydride or NiCad or something horrible like that. And if that's the case, that's really bad. Along the bottom edge of the computer, there's all sorts of excellent expansion. Even though this computer doesn't look like it has a lot of expansion, like it doesn't have internal expansion slots like the Apple II does, it's still extremely expandable. Now on the Master, the BBC Master like this one, it has a built-in disk drive interface. Earlier BBC Micro machines don't always have the floppy drive interface. It's a regular Sugart 34-pin connector, so I can just use disk drives that I already have. There's also a printer port, a user port, a 1 megahertz bus port. So this computer runs at 2 megahertz. So this 1 megahertz bus connector allows you to interface at a slower speed to probably facilitate easier communication over longer cables, things like that. The faster the speed is, the harder it is to drive those signals across cables. And then we have the tube connector right here. This connector, well, frankly, is pretty awesome. This was also on the regular BBC Micro Model B as well. And it allows you to add coprocessors externally to this system. Now, as far as I'm aware, there is a Raspberry Pi project that plugs into this tube connector that then allows, I don't know, the system to run at something like 50 megahertz or something like that. Like it speeds it up dramatically. So it's a pretty cool expansion connector. And as far as I'm aware, all of this stuff was available on the original BBC Model B, except like I said, the disk drive interface was optional on that one. But I know these other connectors, I'm pretty sure, are all there. Then we have this connector right here, which is for connecting up external peripherals that require additional power, since these connectors down here don't provide power, well, any kind of meaningful power. So you would connect them up to this connector right here, and the power supply inside the case sits in this area. Looking at the back of the computer, we have a slew of ports as well. Starting on the left here, we have EcoNet. I think it's like an early networking interface standard that all the BBC machines had. So that was designed for like classroom use. In fact, I think a typical configuration was the teacher would have one of these BBC Master type systems, and then all the regular Model Bs would be connected to it through a network. And I think it allowed for, I don't know, software to allow results to kind of go right back to the teacher's computer, stuff like that. Pretty cool stuff. We have an audio output jack, cassette jack, RS423, so a slightly different serial. A port that's just labeled analog, so I'm assuming analog video, then RGB, which I'm assuming is digital, composite video, UHF, and then we have a toggle switch here, which seems to say loudspeaker on or off. So I assume that just turns off the internal speaker in the computer so that you're not hearing beeps and boops. It does have an internal speaker, and this probably just allows you to bypass that, so you don't have the computer making beeps if you're using this in a production environment, say like in a TV studio. And then we have the power supply here, which does run on 230 volts. And I will need to see about modifying this if it can work here in the US. If not, I'm gonna have to figure out a way to replace it with something that can run 120 volts and provide all the various voltage rails that this computer needs. Now, when it comes to the BBC Master, this one, let's compare it to the original BBC Model B. Here's my Model B, one of the ones I brought back from the UK with me. The Master definitely has a larger footprint, but it's actually not that much larger considering I have it lined up on this side, and it's only that much wider considering they added the actual numeric keypad. Now, it looks like the layout of the regular keyboard appears to be generally the same. The up, down, left, right arrows are in a cross here, and over here they're not. So I would kind of prefer this layout here if you were going to play a game and use those keys. But the rest of the keyboard, yeah, pretty much looks exactly the same. And from a feel perspective, this one doesn't feel very good. That feels pretty nice. I'm actually thinking that could be ALP switches on the BBC Master. Now, as I mentioned, this has cartridge slots that aren't even on the original BBC here. And one thing that is on here is you can actually pull this little cover off. I mean, once you do it, it's off for good. And underneath there, you can install, well, people typically installed a ZIF socket, zero insertion force, and it allowed you to easily and quickly plug in EEPROMs right into the top of the machine. That's pretty cool, actually. But this one, obviously, no one has ever done that. Now, I've modified this to run on 120 volts, hence the kind of modified cable here. In fact, I might just switch out the entire cable now that I have the correct tool, thanks to a viewer that sent that in. Now, comparing to this computer here, we have UHF out, which is over here, there, video out. We have RGB, RS423, and cassette. So that's similar for the DINs. This says analog in, which I guess is what this port is. And then this BBC also has the EchoNet connector there, which is over here on this one. And the power supply looks different between these two machines. Looking at the bottom of the BBC Model B, it looks like it's pretty much identical. We have the tube, we have 1 megahertz bus, user port, printer, and the disk drive port. And I think this one actually has the disk drive interface in it, and it also has that power expansion connector there for plugging in your external peripherals. I think like the floppy drive could actually connect up to that, and you could power the drive directly from the computer. Now, I've had that BBC Model B. I actually have two of them. I bought two when I was in the UK. I've had those for a good number of years, and I've intended to make some videos about them. Neither of the machines I have actually needed any repair. They both worked perfectly. I just had to modify the power supply to work on 120 volts. I actually made a video about that specific task. I will find that video and link to it in the description below if you live in North America and you need to do that same modification. But yes, I'd always intended to make more videos about that computer because it's a whole ecosystem of stuff that were really, really popular in the UK specifically. Maybe not so much for home users, but in schools, that is the deal with these computers. If you're not familiar with it, I will link to a Wikipedia article about the whole BBC microcomputer program. This was a partnership between Acorn Computers and BBC, the British Broadcasting Corporation, to make computers widely available in schools to educate school children so you could have a whole fresh crop of people that were good at programming and ready for the future. I think the original BBC Micro, the one I just showed, came out around 1981. And I think this one came out around 1986. Don't quote me on that, and I apologize if I'm wrong, but after doing a little bit of reading, yes, it seemed like this came later. Now, unlike the BBC Micro Model B, this thing has 128K of RAM, which is more contemporary for later machines. It also has 128K of ROM, so it's got some built-in programs from my understanding. And of course, it's more expandable. There was even factory options you could buy to have an 8186 with 512K of ROM, which could, I think, run some DOS programs, and some other 32-bit processor was available to go in this thing as well. And there is just lots of cool stuff that was possible with these machines. I think my intent for this video is at least to get this computer booted up to the point where we can tell if it's working or if I need to do more repair on it. That means, of course, that I need to open this thing up, and we need to take a look and see if that battery is in there and has leaked. Hopefully not. I'm going to put these into the mug. And once I get that power supply out and we take a look at what's floating around inside of this machine, I think the next step is to see about converting the power supply over to run on 120 volts. Now, I do have a step-up transformer now. The recent video I did on that Macintosh that Tommy sent in means that I can actually run this thing without having to modify it. But I would rather modify, oh, those are longer screws in the back. I would like to modify this, that way I can always use this without having to worry about that transformer. Keep in mind that all of these Acorn machines, the BBC Micro and the BBC Master here, run in PAL. There were North American machines that were sold. I don't know about the Master, but definitely of the Micro. I've never seen one. I would certainly love to know if it were possible to modify these to run NTSC natively. I would think that's possible, but I just don't know what exactly is involved with that. Okay, the computer is kind of coming apart as it is now. I think I'm gonna flip it over. And then we'll lift off the top. And I think the keyboard stays behind. Yes, there we go. Alrighty, so taking a look in here, right off the bat, here is the battery. And I think the battery is normally over here. So it looks like it's been moved, so that's a good thing. That's funny that that's in there, it's just a piece of paper. Looks like this plastic thing here either just sits on there or something. And the speaker, I think maybe that's what was floating around a little bit. There is this, which I don't think it should be bent that way. As far as that toggle switch, which is right here, definitely, that was just used to disconnect the speaker. I can see the little wires there. It looks like they just taped it together. Okay, that works. Now looking over here at this module, that is definitely the EchoNet module. So this is like the networking port, and I see, yes, it has definitely come off. It is supposed to be down there like that. The pins have just bent. It doesn't look like any kind of damage has happened. But right here along the top edge, it says EchoNet module. So that is probably completely fine. And as I had mentioned from a date code perspective, I know it's not gonna be super easy to see due to the way I have the camera set up here. Looks like we have 1986, 51st week, 1986, 49th week. So we can say that this machine was definitely built near the end of 1986. All right, let's get this keyboard out of here. See what's under here. I'm pretty sure the motherboard kind of extends underneath the keyboard there. Now, all things considered, the keyboard is not in terrible shape when it comes to dirtiness, because I think, I have to think dust and stuff just sort of falls down into the keyboard. I want to lift it up because I want to just take a look at what's happening with the battery over here. All right, with those 3 screws removed, seems like the keyboard has been freed up. Nothing particularly revealing on the backside. It's just a nice PCB, and the soldering looks okay. Soldering, let's just say it that way, as they do say it in the UK. I'm gonna pop one of these keys off. Let's just take a look at what we see underneath there. Let's just take this, take off this asterisk key. There it is, there's the key switch. I don't recognize what that kind of key switch is. Doesn't look like anything I'm familiar with, but I would say you could definitely say this is a mechanical keyboard. But what does that really mean anyways? Okay, so here it is. Here is the motherboard. Let's just remove this again. Get the speaker out of here. Definitely looks like a little bit of gunk has leaked down onto the motherboard right there, although I don't see any corrosion, which is a really good sign. So I don't think anything has like poured on there. Does kind of look like something has like spilled into the case over on this side. So the computer will definitely need a full clean, but I don't need to do that now. This should be okay to work. As you can see over here, we have extra ROM expansion. I think that's what it was complaining about, that sticker on the bottom. Do not plug ROMs into here. Use these cartridge slots instead, which are ROM expansion slots, maybe ROM or RAM. This construction here for the way the power supply connects to the motherboard is very typical. The BBC Model B was exactly the same way. Looks like we have like plus 5 volts right here. This will be ground. I think this one is minus 5 volts. So because the voltages are somewhat standard, I could replace this power supply with something more modern that will still provide the necessary voltages. In fact, it looks like the only thing that's being used on this motherboard is 5 volts, which are the red wires. The black wire is ground, and this single minus 5 volts. This is 5 in ground, 5 in ground. So it would be pretty easy to replace this power supply. In fact, I think I have a Meanwell power supply that would probably fit inside this little case and would allow an easy upgrade. And that is only if, of course, I can't modify this for 120 volt operation. Let's get the battery out of here, and it looks like it connects up to the motherboard right here. And what's nice, it's a 3-pin connector, which means that you could plug it in either direction. You're not gonna have a problem with the polarity or whatnot. Appears to be 4.5 volts, I would say, because it's these 3 batteries. And while it has leaked, it has completely leaked over on this side, and that is away from everything over here. But look at that, this just appears to be normal Duracell AA batteries. So any leakage that we'd be getting from this it's just going to be standard alkaline leakage. Isn't that interesting? I can't say I've ever seen that. This looks like it was like homemade or something. To get the power supply out, which is the next step here, looks like I have to unscrew it from the bottom side. Looks like we have 3 screws right here. I would say someone has been in this computer before. At least the power supply has been out. These screws have witness marks on them showing that they have been manipulated at some point in the past. Now, while the motherboard itself does not use anything but the 5 volts and the -5 volts, there's also, I see on that connector there, 12 volt DC output, and that'll be for those floppy drives I mentioned that would plug into there. I'm assuming that's the case. Looks like it also provides -5 and +5 volts through that same connector. All right, looks like it's loose, so I'm just gonna get these connectors off the motherboard. So it's nice they're all labeled very clearly on the motherboard, so reconnection will not be a problem. All right, cables are disconnected. Looks like we have one more screw to take out right there, which disconnects the kind of motherboard from the power supply. This goes underneath like that, and there it is. Power supply lifts right out, and look at that. Doesn't have a cover on the bottom. It just relies on this plastic right here for that purpose. Alrighty, we have moved over to the bench. I have the power supply here. Gonna have to take it apart. There's the plug and the original cord, which I'll have to do some removal of. There's definitely a little bit of corrosion on this power supply. It's interesting how it's sort of a black color there for whatever reason. And over here on this side, a little bit of corrosion. And I'd say the board looks a little discolored there. Maybe it gets hot, something like that. Right here, there's a little bit of rust. This is the back panel there with the power switch. I mean, it's an old computer. Who knows how it was stored its entire life. So anyways, let's take this apart. To get the PCB out, looks like we have 4 screws. And I think there's a couple on the other side as well, which probably are for the transistors. It's probably a heatsink or something like that. Maybe it heat sinks against the top cover of this thing. There's no fan in this computer. I've seen some pictures online of people who have installed fans, like they drilled some holes in the top cover and then they wanted some fan action just to, oops, I just dropped the screw inside. All right, well, that's inside there anyways. See these 2 screws here? I'm gonna take those out as well. Oh, those are tight. Yeah, I think the fan will probably just help keep the entire machine a little cooler. Okay, yeah, it is loose now. Let's see, what do we gotta do here? So that's loose. Bet you I have to take this off. Well, right off the bat, we have a reefa right there, so that needs to change, and there's another reefa right there, so we got 2 reefas. What is keeping this from coming out? Okay, it looks like it's these wires here, so I'm gonna have to cut those zip ties. And with those zip ties removed and the cable loose, I'm gonna have to take out this gland here. I think it's called a gland, cable gland. I'm using the tool that was sent in by a viewer, so you just squeeze it, and then it pops it right out. So once it's out, I should be able to split this apart like that, which takes it off, and that allows the wires to actually feed back through the hole so I can get a little more length. Yep, that's what was kind of keeping it from coming out all the way, plus this, this connector on the front. There we go. Okay, flat blade screwdriver to the rescue. Push that through there. And now this has a lot more freedom. I think we're gonna have to feed these through one at a time. There we go. Now we're left with these here. There are spade connectors in there. I should be able to pull those off with some needle nose here. We'll just snip this zip tie. I'm gonna have to remove the power cord anyways. So that's, there we go. Power supply is free. And let's get this power cord out of here. So there's a ground lead. It's connected with a nut right there. This probably doesn't look like it's very easy to see because of the exposure on the camera. Sorry about that. One day I'll get myself a better camera than this Panasonic one, which always struggles. Okay, so let's see. Let's get this off here without scratching up this label. I did that off camera just because it was a little bit of a struggle. The power switch, the proximity, made it really hard to grab that thing. But I got that off. There it is. And now the power cord is free. So I can, well, once I get this power supply fixed, if I can get it fixed, and I say fixed, it may just be working anyways, then I can replace this power cord, which is exactly what I want to do. Now I just need to get this nut off here. And I want to do it without ripping up my hands. There we go. That came off. There is little washers and stuff. And now the power cord is free. There it is. Goodbye, high quality UK power plug and all those goodies. Let's throw that over there. I'm just gonna cut a regular mains power cord and that's what I'll be installing into this thing. Now, one thing that's interesting is I'm smelling what smells like burned reefa. And notice there's a lot of like, I don't know, a bit of a skid mark in there. I don't know if that's from the reefas or what, but it smells like something let go on this thing. So anyhow, so taking a look at this power supply, let's see what typical problems might be. So this is definitely a very typical flyback switch mode power supply. This computer was designed a little bit later than the original BBC, so this is going to be a slightly more modern, in air quotes, version. There's nothing surface mount on the back. It has this little PCB here, which almost certainly is going to be part of the voltage regulation circuit. There's a potentiometer right there for adjusting the voltage probably. We have some transistors on here. I don't know if this thing uses anything more sophisticated as a controller than just a transistor with an oscillator. There's a transistor down there, and yeah, not a lot of smarts going on here. I don't see an IC, a chip that is, that's doing any kind of, I don't know, fancy-dancy regulation, but you don't necessarily need it. This is gonna work. It's got magnetic feedback, so that's that part right there, as opposed to an optocoupler. That's the magnetic coil. These types of power supplies don't generally enjoy being powered up without a load on them. Usually you need IC control, not just some transistors, to have pretty good feedback range or voltage control range for the oscillator that allows it to run without any load at all. So I wouldn't power this thing up without it. Now it's gonna be a similar design to say the Apple II power supplies. The original BBC Micro power supply looked a lot like this. And I am luckily seeing a way for us to convert this thing from 230 volts down to 120. So looking at the topology of this thing, these connectors right here, this is the mains input, goes through some filtering. There's a reefa there. This is an inductor right here. And it comes through there and you can see those 4 diodes. That's the bridge rectifier that converts the AC to DC. And take a look right there. That's it. That's how you change this power supply over between 120 volts and 230 volts. I just need to install a jumper there between those two, and that should do the trick. From my understanding, the way this works, the way this can run on dual voltages with this jumper link is in 240 volt mode, the AC is converted to DC through these diodes, and then it goes into these bulk capacitors, and this is the transistor right here that does the switching, and it goes through the transformer, which is right here. Now, obviously, if we hook this up to 120 volts without changing this jumper, well, the voltage is going to be stored in these caps is not going to be high enough. It would be like 300 something volts when you have 240 volts going in. Here, it would only be, I don't know, 180 or 200 something volts or whatever it is. It's not going to be enough. So putting a jumper here between those pins sort of creates a voltage doubler so that the power supply still is running at the similar high voltage you would be in a 240 volt country, but it's taking the 120 volts mains input and it's converting that to that higher voltage DC. I'm sure someone who knows more about power supplies could explain this a little bit better than I just did, but that's my understanding. Now, I wouldn't just go rewiring power supplies unless there's something extremely obvious on setting a jumper link there to convert the voltage. That Macintosh I recently worked on is like this, and the original BBC Micro Model B has exactly a similar jumper to this as this power supply, and when I installed that jumper, serviced the rest of the power supply with like changing the reefers and stuff, it works absolutely perfectly. So I have a little piece of solid core wire here. I'm just gonna install this in the board, and that's gonna create the jumper that we need. Just bend that down like that. And we'll just solder the jumper link in place, like so. There we go, that should do it. Now, of course, we're not done with this power supply because I gotta get those reefas out at the minimum. But I'm also gonna check the ESR on this little cap right here. This little cap is awfully close to a bunch of things that get really hot. Let me zoom in there so it's a little more obvious what I'm talking about. There's a resistor right there that gets quite hot, and it's right next to that cap. So if this thing has a lot of runtime, which it probably does, that cap is probably baked. So first, well, I'm just gonna get that cap out and I'm gonna get the reefas out. I might as well just change it because that's just something I have a feeling it's probably gonna be bad. With that cap being bad, this power supply almost certainly won't start up. That has to do with this circuit here that actually runs the power supply. And when you first plug it into the wall, there's gonna be some resistors that feed that capacitor with a little bit of power. And then that should power up this oscillator that starts the entire power supply working. So if that's not working, the power supply may never start or might take a really long time to start. But the most likely problem that's gonna happen is it's just not gonna start at all. All right, I have the two reefas out. Let's get this cap out of here, the small one here. Looks like it is 220 microfarad at 25 volts. And at least it's 105 volt rated, so it's not a typical 85-degree junky cap. With the ESR meter, let's see if I can get this to make contact. 82 microfarad at 3 ohm. Yeah, that's not very healthy. Not at all. Let's see if I switch the frequency, because this thing does actually run at only, I don't know, 100 hertz, because this is going to have DC going to it. 151 microfarad, 5.9 ohms. So yeah, I don't think, it should be 220. So I'm going to say this cap is no bueno. I went into my bag of caps and I found this 270 microfarad, 25 volts. So this should be plenty good to work in place of that particular one. And it's a skinny cap. So it's good. It's a little bit skinnier than the one that's there. So it makes it slightly further away from the, the hot resistor that's there. Of course, it's not like this. The computer is going to be used for thousands and thousands of hours like it was before. What are we getting here? 259 microfarad at 0.4 ohm, and that's at 1 kilohertz. If we change the frequency to the 100 hertz like we were on the other one, 0.6 ohms, 272 microfarad. I'm going to say that this cap here is definitely bad, the one I just took out of the board. Now, before removing this cap, I did mark the board with a minus and a positive so I could tell which way to put it back in, because it's not marked on the top side. Or is it? Actually, there are markings on the silk screen. Can you see that? There's a dot right there, but that dot is the positive side, not the negative side. I don't know if that's normal. The reason why I even know that that's the positive side, because I just looked at some of the other caps on this board, and I could see the dot sticking out under the positive side. Anyhow, we'll just thread the new cap into position. There it goes. And let me find the replacement filter caps here. So we had a 0.1 and a 0.01. Found a 0.01 and a 0.1, and of course they are, the spacing is different. So you just use the old cap to bend the leads into the correct spacing. That's the little trick that I use. And then these should fit right in here without any issue. So all the caps have been replaced. I'm just gonna give this thing a little bit of an inspection now, just to make sure that nothing else looks out of the ordinary on here. I'm not even gonna test the other capacitors on here. Even though this one was bad, I pretty much always assume that the rest of the caps are going to be good. These aren't exposed to a lot of heat, although this diode here is probably gonna get somewhat hot, but these little caps over here are probably fine. Like I said, it's just usually this little capacitor here that experiences the failure because of the excessive heat next to this resistor right there. If these caps are bad, you're gonna get things like a lot of extra ripple, stuff like that, but you're not gonna have a power supply that doesn't work. And pretty much I've never ever seen these caps bad over here. These are the high voltage storage caps. So anyhow, I'm just gonna double check, make sure nothing looks blown up or bad on this thing, and we'll kind of go from there. Everything looks good on the board. I just reflowed some solder joints right there. There's a little PCB that's attached right here to this switching transistor, sticks through the board at a 90-degree angle, and the joints there looked a little questionable. So I reflowed those. I reflowed a few things on the transformer. I'd say the rest of this thing actually, it's in pretty good shape. I'd say it's, hopefully this thing is gonna work. Alrighty, so a new power cord is installed. Unfortunately, the little gland here broke, the original one. I think the original cord that was on here was a lot thinner. I think one of the reasons for that is for 240 volts, the amount of current you have to carry over the wires for the same amount of watts is less. Therefore, you need thinner wires. So this is a 15 amp cord here for North America, 120 volts. And yeah, it's thicker. So this original one didn't work. But then luckily I had some spares here. It's a good thing because this one actually kind of snapped and broke, so I couldn't have reused it anymore. So I have this cord in there now, and you know, it is in there properly. I can pull on this and it does not budge. Now, I didn't have any of these spade type connectors to put on the American cord, so I actually just soldered the little ends onto there. And, but yeah, there we go. We're ready for testing. So I'm just gonna thread this back in and put this power connector on here. I should have probably tested it outside, but whatever, we'll test it inside the case here. One BBC Master 128 power supply converted to 120 volts. And what we haven't done is test it to make sure it works. For load testing this power supply, I'm gonna use this, which is, I think, a turn signal bulb, and I've gone ahead and soldered these clip leads onto it. I just tested this on my bench power supply, and at 5 volts, well, 5.1 volts, it uses about 1.6 amps. I don't know exactly the specs on this power supply. It doesn't appear to be written anywhere on here, but I'm assuming that it can at least supply 1.6 amps on the 5-volt rail. Almost certainly that's the only rail that really matters. I don't think we need to load up the minus rail, and definitely the 12-volt rail doesn't need to be loaded up because it generally is not connected to anything. It's this connector right here. Okay, we're actually ready for testing. So the light bulb is connected. I have it in the 5-volt rail with these nails here, clip leads. It's also connected to the multimeter right here. Can you see that? Yeah, just barely. I have the power supply plugged into this power strip, which is plugged in the wall, but it's currently off. And I'm gonna put some safety goggles on. And you can see the multimeter, and I'm gonna turn this on, and the switch is currently off, but just in case something terrible happens. Okay, there we go. And I'm gonna turn this off, and I'm gonna turn the switch on the power supply, and here we go. It does not work. I'm listening for sound, and there's no sound. All right, that's not a good sign, and I put it all back together. Whoops. I'm gonna do some checking. I have the plug out of the wall here. I'm just gonna check for continuity, make sure that the power switch is actually working. It definitely is. If I turn the power switch off, yep, no more continuity. So we know the power switch, that's good. How about the fuse, which is right here? Well, that is good. This inductor should be passing current, and it is. So theoretically, right here on these 2 pins, when the power supply is powered up, and of course, I have to give the usual warning, very dangerous working on switch mode power supplies. If you don't know what you're doing, there are dangerous mains voltages that can be quite lethal, so please be careful on what you're doing. So if we turn that on here and we check right here, we should have mains, and we do not. I don't understand. How about between here and here? And we do not. I don't really understand what's going on here because we should be seeing, I have this set for AC, we should be seeing 120 volts. Mains coming in, this is on. I was testing continuity and that was working. Once again, let's just double check continuity. I have this on continuity there, 0 ohms there. Switch to this pin. We don't have anything on that pin. And then we have 0 ohms there. That's where the mains comes through. What the heck is going on? The only thing I can think of is that switch is bad, and it's passing the multimeter current, but that's it. It's not passing anything else. All right, what I want to do is I want to try to pass some DC current through the power switch. So currently I have the bench power supply supplying 5 volts. And if we do this, there we go, the light bulb lights up. Takes a moment to do that, but it does. So I have it hooked up to one of the leads on here, and the power switch is on. Let's see. No current there. Okay, there we go. The light bulb came on. So that side of the switch is definitely passing current, no problem. Let's switch to the other pin. Now it should be this one. And it is. And if I turn the switch off, the light bulb goes off and we turn it back on. And that works, 1.5 amps. So it's passing 1.5 amps of current, no problem through that power switch. And let's just double check the ground is working there. So that's working as well. So this is a good way to rule out like any kind of bad connection inside that switch. I gotta say, my assumption here is that there's something wrong with this power strip. Definitely the light was coming on, and that is on the on position, that's off and on. I wasn't getting any voltage through the cable. I mean, I'm gonna grab a different power strip. I don't trust this one. And if it's bad, I'm throwing it away. Alrighty, I have a new power strip and it's currently plugged into my LCD monitor sitting right here. So I know it is good. The monitor was just on. So I'm gonna plug the power supply in. Let's make sure it's on. It is on. Power strip is off right now. I need to make it where the multimeter is visible. I'm gonna put my safety goggles back on again. Here we go. Oh yes, okay. That is more like it. That freaking power strip must have been bad. Unbelievable. Well, hopefully you can see this on the multimeter. It's a little hard to read. We're getting 5.02 volts. Excellent, very excellent. Let's take this off and I'm going to measure the minus rail, which is on this purple wiring harness right here. Minus 5.05, so that looks good. We're getting good voltage there. Let me just check this 5-volt connector over here, see if, yep, 5.04, so that looks good. So this power supply is completely functional at this point. It's absolutely working. Powered up that light bulb with no issue right there. So 1.6 amps or so. It works, and it came right up. Let's turn it off. Okay, it turns off pretty quick. Let's turn it back on. There we go. It takes a second to warm up, but I think the light bulb too also takes a little bit of time to conduct. This is awesome. Great. So that 120 volt conversion completely works. I'll just unplug that to make sure we're safe. So at this point, this power supply is ready to go and we're ready for some testing on the real deal. Okay, let me clean up here and I'm gonna grab the machine and we'll get testing. Alrighty, so here's the computer just as we left it. Let's get this power supply, well, reinstalled. Because I had to cut the zip ties that were holding the wiring here. I ended up using some of those little sticky pads. You stick on there and then you can put a zip tie through it so the wire is reattached, just like it was originally. And I have the power supply reconnected. I'm just gonna, let's just double check. I don't have anything backwards, because if you had one of these backwards, what you're gonna end up with is just short on the 5-volt rail. And no short. I'm just, well, you can't see the multimeter, but it just got a little beep as it's charging. So that looks good. It's pretty easy not to hook it up wrong because it does very clearly say 0 and 5 volts, 0, 5 volts, 0, 5 volts. And this one here says minus 5 volts. So yeah, that's the one purple wire. I think we're good. I have the speaker reconnected. It's just sitting here. And well, I guess I should get a monitor connected. Plug this in here. I'm just gonna need a little BNC to RCA adapter, which I happen to have handy. So we'll just plug that in like so. There we go. I think we're ready to go. I just need to fire up the RetroTink and make sure that's all ready. So when we turn this on, we can see an image. Alrighty, and here we go. I heard a relay click. Oh, is it working? Oh, it's freaking working. This is not a language. Well, that doesn't seem like it's, is that right? I don't think that's right. I wonder what happened there. Okay, well, I'm gonna get the keyboard and we'll plug that in. I'll turn this off though. This is so cool, it actually works. I mean, it works to some extent at least. I did just check with the multimeter that the speaker was turned off according to the switch, so I just turned that back on. There is a lot of cleaning that I'm gonna have to do on this keyboard, but it should hopefully work. Hopefully. Alrighty, keyboard reconnected. Speaker, is this thing sitting there? Yeah, speaker is in, it's turned on. Oh, we're ready for testing. All right, here we go. Making beep noises. I think that's normal though. Asterisk, basic. Oh, the B key doesn't work. Oh no. Okay, we're having problems with keys. Enter doesn't work. Okay, wait, B started working there. Enter, not so much. All right, so we may be stymied from even typing anything. I was gonna try to type the command star basic. I know that commands, I think, on the BBC, you type star in front of them. I'm so unfamiliar with the basic here. Okay, I hit break and that went back to there. So the B key barely works. Oh boy, these keys they're not working very well at all. And from my understanding, when you turn on this computer and it boots up into BASIC, I think it shows BASIC or something, it has the command BASIC. It doesn't just show this Acorn thing. Let me try control break. Yeah, this is not a language. I think control break is kind of like a soft reset. This is not a language. Let's at least try to figure out how bad the keyboard is here. So I'm just gonna type every key on here, see what we get. Wow, some of the keys are just really hard to push if there's something in them. So that's the R key doesn't work, TY, U is not working, I, O. There's a lot that's not working here. At least the arrow keys are working. A, S doesn't work, D, F. There's just big sections of the keyboard that just don't appear to work at all, actually. Before giving up on this machine for this video, I did Google for this is not a language here, and the person says here that they got a BBC Master and it says this is not a language. And the first post here says the battery keeps the configuration. So first thing you do is change the battery and hold down the R key while you turn it on. That'll reset the configuration, which would include ADFS as the default file system. Now press D break, which should temporarily switch to DFS. And this may drop the asterisk prompt or the star prompt. You'll need to do some more values. All right, so you gotta like type some various things in here. And now control break should go into basic, which yeah, I don't think we're gonna be able to do any of that because there's just not enough working keys on the keyboard. Let me see if the R works so we can at least try this reset these default values. There's no battery in here, obviously, but maybe that'll do something. So if we turn this off, oh, you know, I should have checked to see that the R key is even working. I'll hold down R anyways. Oh, look, CMOS RAM reset. Hey, that worked. Press break to continue. Oh, look at that. Cool. It looks like it's high res mode as well. So Acorn MOS is machine operating system. That's kind of like the main OS of the system. It's in ROM, of course. And then ADFS is advanced disk file system. Now the weird thing is what's it doing right now? Oh, you know what? It said to push D break. D key probably doesn't work. So, okay, well that's a problem, isn't it? All right, well, the problem is now, of course, is the keyboard's not working. So even if I find some instructions on how to reset the CMOS settings and put a battery in here, without the keyboard working properly, it's gonna be impossible to type those commands. It seems like you gotta do that reset process, and then that should make BASIC work again on this machine. Before we finish up this video, there's a couple things I just wanna talk about. Absolutely, this power strip is bad. I don't know where I got this thing, but I won't be using that anymore. I did wanna just mention, these are the bad parts that I took out of the machine so far. So 2 REFAs, 1 little capacitor, and then this was the cable gland from the power supply. So far, not bad actually, considering the machine is so old. Also, of course, the battery is also bad, so we'll just stick that there for now. I was cleaning up all the packing material from unpacking the box, and I found these things in there as well. So I have a feeling, well, I don't know what these are actually. Let's just cut this open. I think this feels like a pen or something. And indeed, there we go. We have a couple ARM pens. Let's see what these are. Probably similar. Looks like we have a couple ARM pencils as well. And the last thing, just want to carefully cut this open. I don't want to cut into it accidentally. It appears to be some kind of keychain, obviously, and not sure what the actual symbol is. Anyhow, yeah, you might be wondering what's the deal with the ARM cups, the ARM pens and stuff like that. Well, George actually works for ARM. Yes, the very company that creates the designs that run inside the processors that are inside our phones and, well, everything else. So yeah, and of course, ARM is Acorn RISC machine, as I mentioned earlier in the video, and Acorn is the company that made and designed the BBC Micro and the BBC Master 128 that George went ahead and sent me. All right, there we have it. That's gonna be it for this video. That is the BBC Master 128 sent in all the way from the UK by George. Thank you very much for that. And the jelly, along with the mugs and the pens and pencils and stuff like that. Really awesome. And it's so cool that this computer arrived, well, completely unscathed from its international journey. Of course, the only issue now is After some power supply service, well, the keyboard's not working very well. So I'm definitely looking for tips and tricks from anyone who can give me suggestions on ways to try to fix up this keyboard. Those key switches are soldered onto that PCB, so I'm really not looking forward to if I have to desolder all of those key switches and get them out of there to try to clean them somehow. I do have a large sonic cleaner, like a pretty big one, big enough that I could probably put the entire keyboard as is directly into the sonic cleaner. If that's a way that I might be able to make this work, definitely let me know in the description below. I'm completely unfamiliar with those key switches, so I really don't know what to do. As you can probably tell, I really don't know what I'm doing when it comes to the BBC, so I'm looking for all the help I can get, probably like good beginner guides, places I can find disk images to download and try out software on this thing. Maybe ROM images, I can flash some ROMs and stick it into those empty sockets in there. I'm not sure if that's something that I can really do. And indeed, if there's any PCBs for these cartridge slots and maybe 3D printed cartridge cases I can print myself, then maybe I can add some games or whatever to this thing using ROMs. I don't know. I think that stuff like that is possible. But again, I know pretty much nothing about this machine, so all the help I can get will be definitely appreciated. And I have to say, it's pretty cool knowing that I don't think there's very many BBC Masters here in the United States. And it's really exciting to actually have one for myself and start to explore this cool computer. Of course, the same goes for the other BBCs I have as well. I need to explore those things too. So I think it will be a good learning experience to learn how this thing works. And I'm sure that knowledge will be transferable to those other machines. So if you liked this video, thumbs up. If you didn't, you know what to do. Comment down below if you have insight into this awesome machine. And of course, thanks to my patrons. Their names will scroll up the side of the screen. If you want to become a patron, you can do so at the link in the description below. They get early access videos and stuff like that. And of course, a huge thank you to George for sending in all this awesome stuff. And it's gonna be that. So stay healthy, stay safe, and I will see you next time. Bye-bye.